In this video, we'll use Ohm's law to calculate resistance in circuits that are either in series or in parallel. In an electrical circuit, all conductors, all materials that let electricity flow through them, oppose the current. Conductors, also known as resistors, limit the flow of charge to varying degrees. The extent to which resistors oppose the current is known as their resistance. Ohm's law tells us that for any given resistor, the voltage, V, and the current, I, are directly proportional. For a given resistor, the current in the circuit increases with an increase in the voltage, and the extent of this can be calculated with the equation V equals IR, where V is the total voltage in volts, I is the current in amperes, and R is resistance in ohms, represented by the Greek letter omega. Resistors can be organized either in series or in parallel. When in series, they're connected end-to-end, and the current flows through sequentially. This particular circuit has 3 resistors in series. The voltage of the circuit gets divided between them. Therefore, the voltage for the entire circuit equals the sum of the voltage for each resistor, V1 plus V2 plus V3. Since we know that V equals IR, we can swap the V's for IRs to show that IR for the entire circuit equals the sum of IR for each resistor. Each resistor experiences the same current, so cancel out the I's, showing that to find the resistance of a series current, you can just add together the resistance of each resistor. Now, let's compare this to a parallel circuit. Notice how both ends of each resistor are connected at common points. Each resistor experiences the full voltage of the source, V1 equals V2. In a parallel circuit, the current that goes through each resistor varies, and the total current is equal to the sum of the current across each resistor, I1 plus I2. Ohm's law taught us that I is equal to V over R, so we can swap each I for V over R. Divide everything by V, showing that 1 over the total resistance is equal to 1 over R1 plus 1 over R2. To summarize, let's compare how the V, I, and R relate in the 2 different types of circuit. In series, the total voltage of the source is the sum of the individual resistors' voltages. In parallel, each resistor experiences the full voltage of the source. In series, each resistor experiences the same current, but in parallel, their currents can vary. Finally, in series, total resistance is the sum of individual resistances, while in parallel, the total resistance is equal to the sum of the inverse of the individual resistances, all to the power of -1. Series and parallel circuits are not the only 2 possible kinds. More complex arrangements may involve some resistors organized in series and others in parallel. Let's try an example. Look at this circuit with 2 resistors, one 5 ohms and the other 10. What is the total resistance if the resistors are connected in series? Pause now to try solving the question independently. Let RS be the equivalent resistance of the series circuit. To solve, simply take the equation for total resistance in a series circuit and input the known resistance values. The total resistance is equal to 15 ohms. Now for a second practice question. What is the total resistance when the same 2 resistors are connected in parallel? Let Rp be the total resistance. Take the equation for total resistance in a parallel circuit. Input the known resistance values and solve. Hence, Rp is equal to 3.33 ohms. In this video, we learned how to use Ohm's law to calculate the resistance in circuits that are either in series or parallel. To build your confidence, why not try some practice equations? Like and subscribe for more informative animated explainer videos.